Assalamualaikum. I am Khizr. In today's lecture, we will look at the 5G key technologies of air interface. In our previous lecture, we looked at the challenges we were facing before 5G and what basically 5G is. We looked at the 5G architecture, 5G network slicing and network slicing solution. And in this lecture, we will look at the 5G key technology of air interface. Again, we have the picture that what basically 5G is. It gives us the best throughput of 10 gigabits, 1 million connection per kilometer square and 1 millisecond latency. I explained this picture in lecture number 2 in very detail. Technology 1, in 5G we have a faster race, less delay, more connection and better coverage that we have discussed. And what is relays 15? We have a massive connectivities, means MMTC standards are not frozen yet. What does it mean that MMTC standards are not frozen yet? It means that our connections are increasing day by day. We see it in detail that over 2015 we will have 100 billion connections. There will be only 10 billion will be the people and 90 billion will be the IoT devices. That's why it's saying that MMTC standards are not frozen yet, because the interconnectivity between the devices, person to person, person to device and device to device is increasing day by day. Here we have a Shannon capacity theorem, which is saying that to increase the capacity and throughput, we should increase the bandwidth of the system. This is the point where 5G is working. 5G is giving us a greater bandwidth of 10 gigabytes per second. In this picture, you can see the different spectrum of the 5G. From 1 to 6, we have the main 5G bands, which is called the sub 6 GHz bands or mainly sub 3 GHz bands. After that, the millimeter wave, mainly 28, 39, 60, 73 GHz bands, which are the supplementary 5G bands. And what is the challenges in key technology of air interface? The first challenge is high frequency band have a less penetration and the more path losses. As the frequency increases, it will weak the signal and lose more path, but it will deliver the exact and better communication. And what is the second challenge is, whenever we are downloading or uploading everything, our downloading speed is always greater than our uploading speed. You can see in the picture, here is in line of uploading and here is the lines of downloading, but the 5G technology overcome it. Data rate improvement in 5G technologies. We have coding and massive MIMO, massive multiple inputs and multiple outputs. What is encoding? In the picture you can see the user want to send the messages of 3 packets, but after encoding it becomes the packet of the 9 packet. What happened when we encode the message? We insert some extra file with our actual message that increase the file size. That's why in the picture there were the 3 packets that sender was sending, but on receiving it was receiving 9 packets. To secure our data, we do such type of things. And in release 15 5G EMBP scenarios, we have a control plane which have a polar coding and a traffic channel which has LDPC. Here in the picture you can see the difference between the polar coding and turbo coding. What is turbo coding and what is polar coding? Turbo coding was the coding technique that was used in the previous technology, and the polar coding is a technique that we are using in 5G technology. You can say here's a line of bit error rate and SNR. It started from 10 raised to power minus 1 and as the time increases the bit error is going to downward, but in turbo coding it's going to infinity. We don't know it will go to 0 or remain in errors. What is massive MIMO? Massive antenna array. Massive MIMO is multiple inputs and multiple outputs. In the picture you can see there is an antenna which have the multiple outputs or inputs, and in the picture you can see the single antenna transmitting a multiple signal to the building on the multiple floors. That will help for the faster communication. Massive MIMO has 3D beamforming. What is beamforming? Beamforming is a technique to separate our signal over 360. Like when we are using the technique of MIMO, multiple input and multiple output, we separate our signal in 3D beamforming, mean in 360. In each and every side we scattered our signal. But when we are using single input and single output, the signal direct go to the destination without scattering. We have the multiple user resources and improve the coverage capacity. Here's a different type of beams: 4 wide beams plus horizontal beamform. It is the technology of 88R, which have 4 wide beams, and we can deliver it to the 4 vertical users, like we see in the previous example, that is it deliver its message to the building in the vertically. And here is a 16 narrow beams plus 3D beamforming. 3D beamforming, as I already said, it exits its signal in the 360, means everywhere wherever the user is, it will receive the signal. And finally we have the 5G URLLC with a 1 millisecond delay, ground free scheduling and device to device communication. It's all about the 5G key technology air interface. In our previous lecture we looked at the different 5G scenarios, and in our upcoming lecture we will look at the 5G spectrum. If you like this video, then please like it and share it, and if you have any type of query, any type of question, please comment in the comment box. Subscribe to my channel and hit on bell icon. Thank you.